This is Unit 6, Day 1. And this unit is called Rational Functions. So I want to remind you that if a function is rational, rational means it could be written as a fraction. Okay? So now, again guys, remember, the whole purpose of fractions is dividing a whole into its parts. So back when you guys used to learn fractions, if you just said, divide something in half, you have 2 pieces. If you say divide it in quarters, you have 4 pieces. Okay, so when we're talking about example 1, consider the rational function. It says algebraically determine the y-intercept. You have to know that the y-intercept means let x equal 0. Part B, you're going to algebraically determine the x-intercept, which means let y equal 0. So if x is 0, you're really finding f of 0, which would mean 0 plus 6. You're just substituting in a 0 wherever you see an x in the expression here, and 0 minus 3. So you're going to get 6 over negative 3, which is negative 2. So your y-intercept, when x is 0, your y was negative 2. Okay? So part B, you let y equal 0. Don't forget, f of x means y. So it's 0 equals x plus 6 over x minus 3. The easiest thing is to put it over 1 and cross multiply. So 1 times x plus 6 would be x plus 6. And then 0 times x minus 3 is 0. So now I minus 6 from both sides, and I get x is 0. So the x-intercept, is negative 6. So the x-intercept is at negative 6, 0. And you can verify this using your table, but you do have to memorize these key features, and those are old. Okay? Part C, for what values of x is the function undefined? A function is undefined when its denominator is equal to a 0. Okay? So who cares what the numerator is? It could be any number. It could be just a variable. So you're going to set the denominator equal to 0. Okay? So if you look at the denominator of this, it's x minus 3. Again, it does not matter what the numerator is. So then you need to say to yourself, what number can I plug in right there that would force the entire denominator to be 0? Well, most of us know mental math, and we know that x has to be a 3 because 3 minus 3 would result in 0. Okay? Let's say you don't know that. So you're going to take the whole entire denominator, and you're going to set it equal to 0, and then you solve for x. So you get x equals 3. So having a value when x is 3 is going to make that fraction undefined. The second part of that question says, why is it undefined? Because the denominator would equal 0. That's what makes it undefined. And think about that, guys, with fractions. When I was talking about taking it in half, taking it, quartering it. No one's ever going to say, hey, can you divide the pizza by nothing? Okay? It's impossible. It's an error. Okay? If you put in your calculator any number divided by 0, it's going to say undefined because you don't divide something by nothing. Excuse me. Part D. Based on your Part C, state the domain of this function using set builder notation. Hint, look at the answers from example 3. Alright, so set means you're using curly brackets for all x such that x cannot equal a 3. Curly brackets. So there's my set builder notation. Example 2. Algebraically find all values for which the rational function blah 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 is undefined. Again, guys, undefined means set your denominator equal to 0 and solve. So I have 2x squared plus 11x minus 6 equals 0. So this is a trinomial where your leading coefficient is greater than 2, that does not factor out. So you would either have to use guess and check, okay, or you can use AC method, split the middle, or you could use slip and slide. Okay, don't forget, polyroots will also do this for you in your calculator. So, So using your guess and check, you're going to factor that, and it's going to be 2x minus 1 and x plus 6. Again, you can FOIL, and that should result in this. Okay? Split it, set each equal to 0. And you're going to get x can't be negative 6, and x can't be positive a half. So if either of those values are plugged into the denominator, that would force it to be a 0, therefore it's undefined. So there's two numbers that would make this fraction undefined. Okay? All right, example 3. Which of the following represents the domain of the function? Again, factor it, set it equal to 0. So use mental math here. What number multiplies to negative 16 but then would add to a negative 6? X minus 8, x plus 2. Split the middle. X cannot be positive 8, x cannot be negative 2, therefore it's choice 3. Okay? Alright, so example 4. If g of x equals 3x minus 2 and f of x equals 2x plus 1 over x plus 5, then find f of g of negative 2. So these are compositions. So you're going to want to do this first. So you're going to find g of negative 2, okay? And g of negative 2 is going to result in a negative 8. Now if you're lost and say, how did I do that? A couple ways you could do this. You could use the define key in your calculator. You define each function, you plug that whole thing in. You could graph it, and when you graph the g function, you could look at negative 2, it would have the coordinate negative 8. Or you're going to do it all algebraically. So I'm going to plug a negative 2 in there. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 8. Now you're going to take that answer, and you're going to find f of negative 8. And then you would plug a negative 8 into the f function up here. So 2 times negative 8 plus 1 divided by negative 8 plus 5. And you're going to get a positive 5. So there's your final answer there. Okay? This one, you find g of 2 first. So go to the g function, plug in a 2, you get a 4. Okay? Now you take that answer of 4, plug it into the f function, substitute that in for x in the f function, and you're going to get a 1. So that's my answer. The last one, there's no, roundabout way besides solving it all algebraically, but it means take the g function, plug it into the x. So if I come over here, here's my g function. That has to get plugged in to the f function wherever you see an x. Okay, so now when I substitute it into the numerator, it's going to end up being 2 times the whole g function plus 1, and my denominator is going to be 3x minus 2, that's the g function, plus 5. Okay, so now you're just going to distribute and combine like terms. You're going to end up with 6x minus 4 plus 1 all over 3x minus 2 plus 5. Okay, combining like terms, you're going to get 6x minus 3 over 3x plus 3. You could stop there, or if you factor these, so this is fine, you can stop here, or you can factor it, and if you divide out a 3, you're going to be left with 2x minus 1 all over GCF out of 3, you're left with x plus 1. You notice these cancel, so an equivalent answer would be 2x minus 1 over x plus 1. Okay? Example 5. Find formulas for the inverse. Okay? So if you guys remember back, inverse means you're going to switch the x and y roles. So this is really going to be x equals y over y minus 2. And now we're going to solve for y. Alright, so the easiest thing for me is to put this over 1 and cross multiply. So when I cross multiply this, I'm going to get y times 1 is y. And then I have x times the whole thing y minus 2. Okay? So I'm going to distribute, and I'm going to get xy minus 2x. Then I want to group the y's together. So I'm going to move this to the other side by subtracting it. So those cancel, and I get y minus xy equals negative 2x. Okay? Now I could GCF out a y, and I'm left with 1 minus x equals negative 2x. Now remember, your goal is to get y by itself. So I'm going to divide both sides by 1 minus x. Divide by 1 minus x. Okay, these will cancel. And I get that y is equal to negative 2x all over 1 minus x. Don't forget, an equivalent would be to change all the signs. So an equivalent answer would be positive 2x over negative 1 plus x. Okay, that's also the same as saying 2x all over x minus 1. So any one of these three answers would be accepted. Okay, so part B, we're going to do the exact same thing again. So you're going to switch the x and y rows. So it's going to be x equals y plus 3 over 2y. Put it over 1, cross multiply. So 1 times y plus 3 is just y plus 3. And then I cross multiply. Oops, sorry guys. Cross multiply, and I get x times 2y. Okay? So I end up with y plus 3 is equal to 2xy. So mathematically, you usually put the variables in alphabetical order. Again, you want to group the y's together. Okay? So I'm going to minus this y over there. And I'm going to be left with 3 on the left side, and I'm going to get 2xy minus y. Now, you cannot combine those because they're not like terms. But now I'm going to GCF out again a y. So if I GCF out a y, I'm left with 2x minus 1. My goal is to isolate this y. So I'm going to divide both sides by 2x minus 1. 2x minus 1. Those cancel. And now I'm left with y equals this thing. So 3 divided by 2x minus 1. So this would be the inverse of the original function that was given. Okay. Last example here, example 6. It says, tell whether this function is odd or even. So if you guys can remember, odd functions is a reflection through the origin. And if it's a reflection through the origin, for any point that you are given, it comes out negative x, negative y. In easier terms, what does that mean? You're going to negate or change both signs on your x and y. If it's an even function, it has symmetry through the y-axis, or reflection through the y-axis, which means for any given point, it would result in just an opposite x. So that one, only the x value changes. Okay? So you could pick your favorite number. You don't have to pick 4 and negative 4, but just pick a positive and negative each. The only one you can't pick is obviously 0. So if I went and found f of 4, and then I'm going to go find f of negative 4. So any positive and negative of each. It does not have to be 4. You could use 2 and negative 2, 1 and negative 1, and you go evaluate them. Okay, that should be review. But when I plug a 4 in up here to that equation, I get positive a half. When I plug a negative 4 in, I get negative a half. You can also graph it and just look at the table of values. So this is like having the coordinate 4, 1 half. This is the coordinate negative 4, negative a half. And you can see that both signs changed. Because both signs were negated, this is an odd function. Okay, that's my justification. Part B says, based on your answer from Part A, what type of symmetry does this have? Well, it's a reflection through the origin, which also means it has rotational symmetry of 180. And that's just something that we also learned back in a previous unit. Okay, Part C says use your calculator to sketch the graph. So you can use your table of values once you enter this in your graph. Just please be aware of the increments that were already given to you. Okay, and so this would be like 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. Let me spread those out a little bit better.